Hello everyone. In this video, we are going to discuss the first law of thermodynamics and its representation in isothermal process, adiabatic process, isochoric process, and isobaric process. Let's begin. First of all, consider we have a gas container in which the gas is filled at its initial volume, just say the VI initial volume. And if we provide heat to this system, for example, the delta Q heat is provided to the system, its piston is movable and frictionless. The piston will move towards upward direction due to the expansion as we provided the heat to the system. Now the system will goes to the its final volume, the VF, because the pressure of the gas is exerted the force on the lid and the lid will move upward direction. As we apply the heat to the system and its piston is uplift, then the heat provided to the system goes into the two forms. It's change in internal energy plus work done. This equation is called the first law of thermodynamics. We can change this equation as well. The delta Q is equal to the change in internal energy plus work done. We know that the P delta V. Here, the delta Q is heat provided to the system and delta U is this delta U is change in internal energy. And P delta V is work done. The change in internal energy depends upon the temperature of the system, because the change in internal energy means the sum of all energies, kinetic energy and potential energy. Means it is equal to the change in internal energy is equal to the sum of all kinetic energy plus potential energy of the system. As potential energy goes to zero for the ideal gas, because the ideal gas there is no interaction between the molecules and they exert no force on each other. If the force is zero, it implies that its potential energy is also zero. Then only the internal energy left with the kinetic energy. And we know that the average kinetic energy of a ideal gas for monatomic is equal to 3 by 2 kT, and we can say that the average kinetic energy of molecules only depends upon the temperature. The internal energy is only depends upon temperature for ideal gas. Now we consider isothermal process. For isothermal process, the first law of thermodynamics will reduce to, as we know that the isothermal process is a process in which the temperature of the system remains constant. If temperature is constant, then change in temperature is zero. It implies that the change in internal energy will also zero, because we say that the internal energy only depends upon temperature. Then isothermal process, the first law of thermodynamics will become the delta Q is equal to 0 plus P delta V, and the internal energy is equal to P delta V for isothermal process. All the heat we provided to the system goes into the work done. There is no change in internal energy for the isothermal process. Now consider adiabatic process. For adiabatic process, we insulate if we insulate this cylinder so that the no heat can enter the system or leave from the system, then the first law of thermodynamics will reduce to, as the delta Q is 0 for the adiabatic process, then delta Q is equal to change in internal energy plus work done will become 0 is equal to change in internal energy plus work done, and we can say that the change in internal energy is equal to the minus work. This equation tells us that change in internal energy is positive, but the work done is negative. If internal energy positive, it implies that the internal energy increases at the expense of the work done. Negative means the work done is on the system. On the system means the system will compress. If we compress the gas, its internal energy will increases and there is no heat enter to the system. We can also write this equation as this: the internal energy negative is equal to work done positive. We place the negative sign with internal energy. If we place the negative sign with internal energy, it implies that the internal energy decreases, but the positive sign is here for the work done, and the positive work means that work is done by the system. Means if the gas expands without entering the heat, if the heat enters to the system is zero and the system expands, then the internal energy will decrease and the work is done by the system. Now consider the isochoric process. As we know that the isochoric process means the volume is constant and constant volume, the work done is zero, all the heat goes to the system will convert into its internal energy. We can write here that isochoric process. For isochoric process, the delta Q is equal to change in internal energy plus work done, but work done is zero. That's why the delta Q is equal to all the heat enters to the system goes into the just internal energy change to its internal energy. For isobaric process, the pressure is constant, and if the pressure is constant, our equation will be like this: the delta Q is equal to delta U plus P delta V. Now if we draw the graph PV curve for these four processes, then now draw here. Let's say x-axis is volume and y-axis is pressure. Then there will be a straight line in this direction. It implies that the pressure is constant throughout the expansion. It's this line, horizontal line, represents isobaric process. And if from this the expansion goes like this, the system goes from A to B, here from A to B and here from A to C, then this process is called isothermal process, in which the temperature remains constant. And if the curve goes like this from A to D, it is also expansion, but it's a adiabatic expansion because its slope is much larger than isothermal process. It is called adiabatic process. Slope is higher because here exists for adiabatic process the PV gamma is equal to constant, but for the isothermal process here the pressure is inversely proportional to just volume power 1, and here for the adiabatic process the pressure is inversely proportional to the volume power gamma, and gamma is greater than 1. If the value of gamma is greater than 1, then the pressure will decrease with a fast rate. Now, and the fourth process is isochoric process, and for isochoric process we can say the graph will goes like this. It is not expansion nor compression because the volume remains constant and the pressure decreases, volume remains constant. This process represents isochoric process. You can take the screenshot from here. Thank you for watching.